Hi, welcome back to part 2 of the Smart Mobility Summit. I'm Shane Rooney from the GSMA, and in this session we're going to be talking about the new advanced mobile technologies that are going to help to create a smart mobility world in which we all live in. And those technologies are obviously things like 5G, but also mobile edge computing, embedded SIM. We're going to talk a little bit about maybe on network slicing and quality of service that we're associating with that. So without further ado, I'm going to invite our first speaker up, Leticia López Domingo, who is the absolute expert at Telefónica on vehicle communications. Leticia.
Firstly, thanks to the GSMA for giving me the opportunity to be here, to participate in this summit, and to share with you what is our vision, our value, and what projects we are working on. I'm sorry, because I want to... This is not... Yeah. Let's start with the technological pillars. As you can guess, our main value are our network capabilities, led by 5G mobile networks. All of us here, I think that we are already aware that 5G is a key player in the smart mobility with great capabilities in terms of massive connectivity, large bandwidth, and what is most important for mobility, ultra-low latencies. 5G network also integrates cellular V2X technology that allows vehicles to communicate with their environment. But 5G networks have to evolve to their best version. What I mean is that 5G network doesn't arrive all at once. It arrives into phases because the standard have established that way. Today, we have developed the first phase of 5G. From this year onwards, we are going to develop the second phase of 5G on its own bands, its own spectrum, and with a complex transformation on the network core that has to mature all over the course of this year and future years until it reaches its maximum expression that is called network slicing. Network slicing is a key capability that allows 5G networks to be subdivided into multiple subnetworks that adapts to the demand of every use case or even customer. In the specific case of mobility, we will have a subnetwork dedicated for vehicular communications in order to guarantee these communications, separating them from the rest of the traffic. This is really important. Network slicing will be a reality in 2024, and together with the development of the applications running on the edge, both of them will be two essential components for the democratization of future connected mobility and future automotive solutions, just being able to guarantee the service all the time. On top of these network capabilities, Telefónica is building in an enablers layer. Enablers because they enable the different use cases. We have been focused on three enablers. First one, the application management running on the edge, together with a set of algorithms based on artificial vision, artificial intelligence, and machine learning. The second enabler is a location service that provides very precise positioning with a centimeter-level margin of error. And the third enabler is a platform key infrastructure to ensure vehicular communications and to create a trusted V2X ecosystem. Telefónica, with these two layers, provides the basics for the development of the future smart mobility. There are several use cases. Telefónica, we have been focused especially in B2X use cases. And we have developed several cellular V2X use cases framed in 3 ecosystems: smart cities, smart roads, and smart industry. All of these trials, as you can see, we have developed them with very important players in the automotive industry, because it's really important just to make an ecosystem of partnership. And in all of these trials, we have combined 5G network together with edge computing for lower latencies and also cellular V2X. Regarding the enablers layer, we have deployed them as long as the use case needed and, of course, as long as the technology evolves. In 2019, we started with Smart Cities ecosystem, and we tested in real environment the first assisted-driven use cases. We connected vehicles with traffic lights. We tested some day one as vulnerable road user detection or emergency vehicle warning. And in these cases, we used the edge. It was at the beginning, and we used the edge just as an intermediate server. The edge computing gathered all the information, collected all the CAN messages, and resend them just to the relevant vehicles. 1 year later, we moved to smart roads in order to, you know that the digitalization of roads is really important because it's where the high number of fatalities occurs. And we developed the first 5G connected tunnel in Spain. This tunnel sends information to drivers about the atmospheric condition, the weather conditions at the exit of the tunnel, and also warnings about what's happening inside the tunnel. I mean, a slow vehicle, a pedestrian, a congestion, an obstacle in the road, any anomaly. We deployed 5G coverage inside the tunnel and outside the tunnel, and we sensorize it with several IoT sensors and with a lot of cameras, CCTV cameras, thermal cameras, OCR cameras. And in this case, we add intelligence. In the edge computing, we develop an ITS system, intelligent transport system, and that detects all the information, collects all the information gathered by the IoT sensors and cameras, process it, and sends the warnings. Last year, we had the opportunity to take cellular V2X technology to an industrial environment, specifically to a port terminal with the customer APM terminals that is here in Barcelona, and with the objective of making the port safer and minimize the risk of collision between these cranes, trucks, and the staff in the terminal. In this trial, we developed the second enable, the precise positioning. And we use technologies like RTK correction, GNSS, just to provide this accurate precision, the centimeter level margin of error. In the future, we will have traffic lights, we have vehicles, we will have tunnels connected via 5G, exchanging information, exchanging data. The quality of the data becomes critical, and it's necessary to develop a cybersecurity layer just to ensure these communications and to avoid any type of cyber attack like spoofing, man in the middle, etc. And we have been focused on that for the past year, and we developed the third enabler that I told you at the beginning of my presentation, the public key infrastructure that ensures both the integrity of vehicular communications and the trust between all the players in the automotive industry. This platform generates and sends batches of anonymous certificates to vehicles, to traffic lights, to road infrastructure, in order for them to digitalize all the messages that are exchanged. This platform is integrated in the cybersecurity node of the European Commission, so we are glad to share with you that Telefónica is the first telecommunication carrier to have a certification authority recognized by the European Commission linked to 5G for vehicular communications. To demonstrate the importance of this cybersecurity, we developed a demonstrator together with DECRA, Nexus, Harman, ZTAG, and HP, and we implemented several B2B and B2I use cases. We still have this demo in Malaga, in the facilities that DECRA has in Malaga, and we invite you to go to Malaga, to visit DECRA, and even to test with it and to integrate with our platform. Now here are some of the projects that we have been working on. As you can see, Telefónica is fully committed in helping define and develop the next generation of connected mobility, automated vehicle, and intelligent transport systems. Mobility in general, the automotive industry in general, needs better security, more efficiency, and more flexibility. And we believe that 5G, edge computing, and cellular V2X will be essential for achieving this. Thanks.
Thank you, Leticia. I hope that's given you a bit of insight as to how a mobile operator is working with its partners on the new technology that will give us the new smart mobility solutions of the future. So our next presentation actually is a double act. I'd like to invite André Schlufter from Porsche and Niclas, Mattheus from Vodafone to share with you what work they've been up to. And I hope you find this interesting. Thank you.
Niclas, give me a clicker.
Hello and welcome to this joint presentation between Porsche and Vodafone. As some of you might already know, we are working since years together in the IoT and connectivity area. We also have a Formula E partnership, which was one of the various starting points to also talk about customer vehicles and about upcoming features. In this presentation, we would like to give you an overview about our joint research, what we are doing in the 5G, V2X, and MEC area. And before we go into the topic, let's introduce ourselves pretty quick. My name is Niclas. I'm a multi-axis edge computing solution architect within Vodafone Business. And I'm today joined by my dear colleague from Porsche.
Yep. Thanks, Niclas. My name is André. I'm responsible within Porsche R&D for the connectivity on global scale. And I would like to start to introduce what is the Porsche offering today based on eSIM connectivity. So we are using this connectivity for connected navigation, media and infotainment services like CarPlay, but also included services like Apple streaming. We have enabled function on demand, software updates, everything based on eSIM technology. And of course, it's not only that, it's emergency calls and connected infotainment. When it comes to EV services, of course, your remote services are quite important that you can see the state of charge of your batteries. With our latest PCM, we are updating the functionality to introduce Android wireless auto. We have a native integration of Spotify, as well as improved voice pilot and an optimized charging planner. But we are not stopping there. We are looking into the ecosystem of our customers, and there, over the past years, we have developed several apps to allow the customers to remotely control their vehicles. And we are recently launching a program to enhance this by combining all these different offerings into a single My Porsche Connect app, which allows the customer to remotely control the vehicle or plan the charging trips. But as Porsche is famous for the performance on the track, we have also a special offering for our customers there. You can use this app, the Porsche Track Position app, to train your skills on the track. Over 300 official racetracks already integrated. You can learn, improve your skills, and share videos of this with your friends. But we are not stopping there. So since 2017, we are working to improve also safety for our customers. Therefore, we have introduced a service called Local Hazard Warning, which is basically working that a car running in front is detecting accident or any hazard on the road. It's reporting this up to the cloud, and every following car can download this event and get warned in advance. The limit there today is it's updated once per minute, and there we have partnered with Vodafone in order to improve the situation. And I would like to hand over to Niclas to explain us how.
Thank you very much, Andre. We have identified together with Porsche some features in the future which are interesting. The following features is what we identified. First of all, C-V2X will change everything. We will be able to interconnect road users even over miles. We will have the possibility to then add, of course, technology to see virtually around corners. We will use sensor fusion for that as well. And one of the major points we from Vodafone side at least see is that in the future we are able to decouple the software from the hardware of a car for advanced features. Other car manufacturers, for example, are adding big GPUs to their cars for machine learning, for everything else they need in the car. This is, of course, draining a battery. This is minimizing the range of a car. And we ask ourselves, hey, why don't we offload non-safety critical tasks out of the car into the Mac with 5G, with low latency in between, because that can be in some way technically possible. We also see that for features like fleet management, precise positioning, usage-based insurance, and HD live mapping, big data preprocessing at the edge could be of benefit. And all of this is a starting point or the basis for autonomous driving and more advanced features in the future. And one other thing is, of course, the future potential to have entertainment in the car. But who wants to have entertainment in the car when you can drive a Porsche? But that's another topic that's not for a discussion for today. Before going into what is needed to enable these features in the future within our network, let's take a look at what is the current architecture. This is an illustration. Of course, at the beginning, you have a car connected with a SIM to our network, and that takes around 10 milliseconds. Then the data is at the base station. Then, of course, the base station is connected to our core, then connected to the internet. That takes then additional 15 to 20 milliseconds. And then the data needs to go from, of course, the internet connectivity to the Porsche backend, for example. And then, if you're lucky, the device is, or the car is located in Germany, the service already in Germany, then we're speaking about maybe additional 30 milliseconds. If you're also lucky, the service located in the EU, then we're also quite good, but it is still no low latency. And if the server is located in the US, we can have an additional latency of up to 120 milliseconds. And then we have not considered any third-party services like music streaming or advanced driving information. So what do we have to change? We have a 55 to 150 millisecond latency in total. We need to bring that down drastically. And with the help of 5G and Mac, we were able to do that. The car is still, of course, obviously connected to a base station. But with 5G, we are minimizing that latency to 1 to 2 milliseconds. Then the base station is also connected to a core. But we are here into the core embedding edge computing. We are already doing this as Vodafone. We have MEC live in 4 European markets where MEC is connected to the public 5G network. This offers customers edge computing with cloud advantages, and we're not stopping here at the edge. We are minimizing, first of all, the latency from 55 to 150 milliseconds down to 10 milliseconds in a feedback loop. That is massively. And we also see that we have to have a connection from the MEC side back into the cloud of Porsche, for example, where data can be processed, where the back end is laying. So we see we are bringing a part of the cloud nearer to the vehicle, and we are enabling use cases that are only possible by low latency, and third-party services can also be embedded into our MEC. We now have some advantages when you compare the current architecture to the future architecture with 5G, V2X, and MEC. First of all, we have a location awareness. That means all components are working together to minimize the latency. We have to have a car which is driving from Barcelona to Munich, for instance, to plan together with the network and the compute network MEC region handover. We also have an interoperability that backends are extended and interconnected at the edge. We also see an example on the next slide. And because everything is within our Vodafone network, we're able to predict pretty good the latencies in the future. And this enables future use cases together with low latency because it feels for the user, for the driver, that the data is being processed in the car when it is not actually. And we also see that MEC is complementing cloud. Not everything needs to go into the MEC. That doesn't make sense. Only the low latency and time-critical services with a critical feedback loop, they can be embedded into the MEC. And we see in the future that we have an intelligent workload placement, which allows to sort these things out. And we also see that big data processing with millions of cars on the streets in Europe will need much more data traffic and processing power than we have today. And we have already one example here. We as Vodafone, we launched end of last year a V2X message broker. This is managed by Vodafone. It connects road users to each other. We also have free usage for safety-relevant messages in place. It is also possible to deploy time-critical services on top of our message broker. For example, a VRU awareness service. We will have an example later. And we also look further into exposing that message broker to road operators and partners, and we hope to have also an interoperability in the future. Thank you very much. Back to you, Andre.
Yeah, thanks to the partnership with Vodafone, we have been able to update our development center in Weissach, having latest 5G technology on site, as well as support of 5G standalone, as well as mobile edge computing. So based on the sponsorship of our CEO levels, we have been able to integrate use cases already. So one of them is like remote rendering, which is quite interesting approach for us in the development that allow us potentially to offload some compute from devices with limited compute power to the cloud. And another use case where we have a video with us showing this is the VRU proof of concept we have working together on. For that one, we have also partnered with HERE, which is the #1 location platform solution provider in the automotive. And yeah, let's play the video to show this.
Combining location technology with 5G introduces powerful solutions for safer, less congested roads and better driving experiences. That's why HERE Technologies, Porsche, and Vodafone are collaborating on a proof of concept to enhance road user safety. With 5G's ultra-reliable data speeds, sharing real-time information becomes possible, helping drivers to become more aware of potential hazards around them. This is made possible by leveraging Vodafone's 5G multi-access edge computing network with HERE's HD GNSS for precise positioning, trajectory and location relevance analytics, and LiveSense vision technology. Visual detection algorithms from LiveSense SDK turn vehicles fitted with cameras into highly intelligent sensors. Let's take pedestrian visibility, for example. Pedestrian detection data from vehicles is sent to Vodafone's 5G and multi-access edge computing network for analysis. If a pedestrian is set to cross the trajectory of vehicles nearby, the relevant vehicles are notified of their presence and movements, even if the alerted vehicles can't see the pedestrians themselves. All of this just takes milliseconds. Thanks to the combined efforts of HERE, Porsche, and Vodafone, the future of road safety is here today.
Yeah, thanks. So maybe to... Can you still hear me? Yeah, so... yeah, thanks. So we have seen this was a proof of concept we are working on to use the Vodafone Step platform introduced by the Vodafone team, and you probably have noticed, so we are very happy to be here today because you have seen Niclas was the pedestrian. I was the driver in this scenario, so system is working, and we are happy to be here too. And thanks for the GSMA to invited us to showcase this to you.
Niclas and Andre for that. I'm sure that's a great example how partners are working together to create smart mobility solutions using technology that's here now and about to happen. Our final part of this session is a panel session, and so I'd like to invite our panelists and moderator to join us on this. And it's going to be April Wirtz. Mark, you're on the next session, I think. You've jumped the queue, I'm afraid. That's the next moderator in the next session. So April Wirtz from Accenture, Tim Sagar from Thinkware, Johannes Springer from Deutsche Telekom, and Sam Brown from Valid. So if you'd like to join us, please, that would be great. Thank you.
Great. Well, thank you everyone for joining us here today to talk about what I believe is one of Mobile World Congress's hottest topics here, smart mobility. And achieving the smart mobility revolution and vision really requires connectivity at the basics, at the foundation. And connectivity needs to be reliable, consistent, widespread, and as we've seen a lot from the presentations that we just saw, there's 5G that is also unlocking a lot of new use cases for the smart mobility revolution. I believe that communication service providers play a critical role in this ecosystem to connect mobility and the end users. I'm very happy today that we have a panel that represent different aspects of this ecosystem and are going to be able to talk to us about all of the different players that are going to be required for the smart mobility revolution. So with that, I would like to first ask the question to Johannes as to what really does make mobility smart, quote unquote.
Yeah, thanks, April, for this question. What is a smart mobility ecosystem? And I think we had seen already great examples. Smart makes an ecosystem if everything is connected with each other. So who are the ecosystem players, of course, which need to be connected to each other? These are the ones who are sitting in a vehicle, whether these are drivers or passengers in a vehicle, the ones who are using also the road but not sitting in a vehicle, and very often, and that is something we need to face as a society, the ones who are creating a lot of fatalities, the vast majority of fatalities, sitting on a bike or being a pedestrian. But this is also, of course, the road infrastructure. So the traffic lights, the variable message signs, speed limits, parking signs, and the road as such. So if we are talking about HD maps, it's a digital road and a digital twin of the road. And to provide this information and all this information, to connect all this information with each other, this makes at the end, creates at the end a smart mobility ecosystem.
And Tim, maybe you can speak a little bit about your perspective on what is here, what is now, what is real, and what is next, and what is in the future.
So I work for ThinkWare. I've been with ThinkWare for about 8 years. ThinkWare is a Korean company, and you can view them as the equivalent of Google Maps. So South Korea is still a war zone, technically, and so Google is not really allowed to offer the same services. So whereas you have street view vehicles going around with Google in the rest of the world, in Korea they are ThinkWare vehicles. And ThinkWare started as a sat-nav company and has its own mapping database and has something like 60% market share of the Korean domestic market. But when smartphones arrived, then sat-nav started to wane a little bit. And so ThinkWare went into dash cams. And so ThinkWare have 40% market share in the Korean domestic market, and the market is about 2 million pieces. So the penetration of dash cams is something like 70%. So if you walk down a street, every single car will have a dash cam in it. And so in terms of offering the services, then the players that need to be involved on the security side of things, we try and do a lot of security things within the dash cam in terms of lane departure warning, forward collision warning, so everything is done by the camera. And then when we offer the services with our LTE connected service, then we need other players. So we need a server to be able to monitor where the vehicle is. But then in terms of security, in terms of SOS, then there's an SOS button, but there's also an automatic SOS generated. And then it needs to be a call center linked into that to be able to receive those messages and then act upon those messages. So the SMS that sends the emergency contains the Google Maps location, contains the phone number of the account holder, and also it uploads a video clip 10 seconds before the event to 10 seconds after. So the call center can then assess what's necessary, call the driver to offer assistance, but if it's clearly a major accident, they will call the emergency services and coordinate that from the call center.
Thank you, Tim. And Sam, maybe you can speak a little bit about Valid and the role that your company and your experience plays in the ecosystem of smart mobility.
Yeah, exactly. So, hello? Okay. Yeah, exactly. So, rather than major players, I think we're seeing major parts of the ecosystem. So, Johannes and Tim and Porsche have touched on some of those things in the ecosystem. At Valid, we're really in the technology enablers space. So within that space, you've got the modules, the chipsets, and we sit in there as the eSIM providers. So we're enabling that secure, seamless, always-on connectivity that's provided by the connectivity operators. So there's really different parts in that space. Instead of at the moment, major players, we should see it, I think, as major parts. So the mobility companies, of which the automakers are transitioning to become mobility companies, and therefore offering multimodal options. And then we've got network vendors, as we saw, offering edge computing, massive machine type communication, and the roadside units needed for cellular vehicle-to-everything technologies. And then once you've really got all those devices connected, we work very closely with device makers to ensure that they integrate properly and connect efficiently. But once they're connected, then you need the platforms there to manage the devices and manage all of the data that these devices are creating. So that's where we'll see hyperscalers play a role. We'll probably see that in the third section of the summit. So we really should look, I think, at not major players, but major parts with players with major roles in the ecosystem.
Great point. And Johannes, given that that you have a role with a mobile operator focused on 5G and automotive, what do you really see as the role of the communication service providers going forward, the role of the operators, and some of the opportunity there?
As I said, we are providing the networks with all the relevant capabilities to connect all these different pieces with each other. I would like to stress one more point, which is, from my perspective, very important when we are discussing with automotive customers, but also, of course, with the road operators who want to distribute their information to the participants on the road, or who want to get access to the data which is coming from the road participants, and that is quality of service. In the past, of course, we as mobile network operators have some features like safety or emergency services which are already managed by a certain level of quality of service compared to the other normal customer services in the network. But this is definitely not sufficient. So, and of course I can visit everybody to visit us at the Deutsche Telekom booth. We believe strongly in quality of service and how to organize quality of service for the different use cases of the automotive, but also of the road operator industry. Because we cannot any longer operate our networks in a best effort style. We need to differentiate the different classes of use cases according to the different quality of service needs. So whether it's in a tunnel, whether it's at a certain intersection or a section crossing, or somewhere in a rural area, connectivity need to be provided anywhere, anytime, under any circumstances for the mission critical services. Otherwise, maybe you will be not here because you are killed. And that's exactly what we need to organize in our networks. And that is, of course, a huge challenge. Yeah, it is a serious task. It needs to work globally as a harmonized approach across various operator networks. And it's also a huge challenge here for the GSMA to take care that all the operators worldwide are aligned in a way that we are operating our networks in that exactly way so that it fulfills the requirements of the automotive industry.
What is needed for that global alignment, for the global widespread connectivity?
Of course, global cooperation, it's a must. Yeah, and we are already cooperating. We have around 600 partners around the globe where we are cooperating. It's not just one network in a certain country where we have our network footprint. No, we need to operate on a global basis to provide global connectivity. But this is not only global connectivity from the past in the best effort style, but all the contracts need to be enhanced in a way that mobile edge computing can be operated on a global scale, that network slicing can be operated on a global scale. Otherwise, it will not work. And that's exactly what is needed, this type of collaboration model, this type of cooperation model, and that's exactly where we are, what we are going for.
Tim, building on that, can you speak a little bit about what it would mean for ThinkWare, for your products, for your market opportunity, if there were more of the global standards and increased reliability and consistency of connectivity?
So I think the word is consistency of connectivity.
Okay.
And the headline in the UK Fleet News was horror, 2G is going to be switched off. Because there are a lot of vehicles with telematic systems still operating on 2G because it's got the coverage. So there's a lot of people worried about that particular situation. With ThinkWare, in Korea, you have good coverage of every single network you can imagine. And we developed an NB-IoT modem to go with the dash cam to offer connectivity. Trouble with that is it didn't have the handover. So the next version was an LTE-M system. Now we launched that in Singapore. Now you can cover Singapore, no problem at all. But then when it comes to the UK, I looked at it, and even today, there's only half of the UK covered by NB-IoT, and the other half is only covered by LTE-M because it's a network sharing between O2 and Vodafone. One went NB-IoT, the other went LTE-M. So unless you have nationwide coverage, you can't even offer the service. And the advantage of LTE-M is it's got a 20 dBs of better coverage, underground car parks for vehicles and so on. It's fantastic. So the basic coverage needs to be there, otherwise the service cannot be launched. And even today with LTE, so I did the North Coast 500, which is the route around the north of Scotland, around the coast. And I was using a Vodafone Smart SIM, which has national roaming. I was probably out of coverage maybe 50% of the time. That's no good with an emergency service. So coverage, as far as vehicles are concerned, are absolutely everything. So to talk about 5G, your autonomous vehicles, as soon as they come to the edge of the 5G network, they're going to stop. Yeah. So it's going to be a long time before 5G has that ubiquitous coverage. So it's all well and good in the lab, but when you come to the real world, then it's a completely different story.
So Johannes,
maybe,
yeah, please.
maybe I can say a word. Is the microphone working? Yeah, great. Maybe I can say a word to that with respect to coverage. You know, we will hardly see a situation where we have 100% coverage by terrestrial networks. You know, so we need to face always situations where we don't have coverage. Of course, the situation shall be limited as much as possible, reduced as much as possible, but we need to face it. And you know, thanks to the automotive industry, they know very well how to face it. You know, if you have an automated lane keeping system in your nice Porsche, of course, this system works not 100% in all the cases. In the middle of Scotland, somewhere at the rural road, one pass lane or something like that, no, that maybe it does not work there. So the important thing is here to have, of course, an informed customer who knows exactly what's going on and who knows when and where he needs to take over the driving responsibility if it's an automated driving vehicle. So we have, and we talk already in the automotive industry about so-called operational design domains. And these ODDs are, of course, limits. They have limitations. They don't need to work everywhere at any time. But on the other hand, I don't want to use this as an argument not to do everything to be everywhere and any time to deploy and to have a proper functioning network. That's clear.
Please.
So I think everyone needs to watch Tesla because Elon Musk has a whole network that he's building with satellites, and you have ubiquitous coverage. So I think the vehicles need to have maybe a satellite backup for when they lose coverage terrestrially.
Well, I think what will also be interesting to see is where does the liability fall as we go forward as well? Is it with the the OEM, the vehicle provider, the connectivity provider, et cetera. And as you start to talk about safety and human safety as well, that that's going to continue to be a debate and something interesting. Yeah, please.
Yeah, I think a lot of the things we're talking about is showing the challenge of integration. We're talking about integration of these massive IoT devices into the mobility ecosystem, including people, including different networks. So the challenge there is really integration, I think, between technologies, between users, between devices. And with that integration brings the opportunity, right? So you're going to see like new services come around from that integration. And eSIM can obviously help with that. It doesn't make it perfect. As Johanna said, in 100% of cases you won't have coverage, but you can enable different networks with that technology. So you have the ability to switch. But yeah, I kind of hear, again, integration coming from different points. I think it's an important thing that we need to focus on.
Yep.
Maybe one point also, because, you know, I like this very much about mobile edge computing. Yeah, so we did already the same, and, you know, that exactly shows how also the ambitions of the different mobile network operators operating in a certain country need to be integrated. You know, if we have one mobile phone subscription in the car, which is offered by Porsche, which is coming from Vodafone, but unfortunately you have a customer as a pedestrian or as a cyclist who has a Deutsche Telekom subscription, how can we make sure that the whole thing is condensed and fused in an edge cloud, which is on the one hand provided by Vodafone, or on the other hand provided by Deutsche Telekom? So that needs to be done, yeah. And we did already this nice integrated testing in Germany together with our colleagues from Telefónica, where we showed that, of course, also the mobile network operators can collaborate in a way that edge computing can be provided as an infrastructure out of various mobile network operators. And that's exactly the way we need to go.
Yeah, fantastic. Well, with a few minutes left, actually, I would like to ask our panelists if, well, either what are you most excited about for the smart mobility revolution, or just any other closing thoughts that you'd like to share with the audience? Anyone can go first.
I'll go. Go on.
Yeah, I just... Hello? Okay. I just think, again, back to the integration, you know, if we can integrate those devices, we'll see services that we've never thought of before. You know, it wasn't long ago that we could never imagine our vehicle turning our home heating on as we're driving home, but doing that automatically for us. Or checking the front door is locked of your house when you drive away. So there's like endless opportunities when you integrate those devices, the IoT in the mobility space. And I think, well, that's what I'm excited about.
Great. Go ahead, Tim.
Yes, I wouldn't say I'm that excited. It's going to be an improvement, because at the moment with my system I get an immediate notification if there's been an impact, or if the vehicle is parked, or those immediate notifications. But then I have to wait probably about 30 seconds before I can then see the video. So it takes a while to upload, and in this world we like to have things instantaneous.
Right.
So to sit and wait for the video to upload, it'd be good to have that better speed, so I can benefit from that. But I'd like to see also some dedicated tariffs for IoT applications. So we partnered with Vodafone because they have a special IoT smart SIM. The condition is that you're not allowed to access the open internet, but at least it's providing connectivity for that particular device. And therefore you can offer much more affordable tariffs for these kinds of applications. So we're now looking at being able to offer, I mean, we started with LGU Plus in Korea, where the camera was actually sold with 2 years of connectivity. So we're now looking at being able to sell the camera with 2 years of connectivity for the service, which will be much more affordable and also plug and play. So the user just plugs in and off he goes. Because there's such a user barrier in terms of getting everything, registering the SIM and entering all their details. So we have to make it much easier for it to be adopted by the general public on a widespread basis.
So maybe not excited, but hopeful. We've got excited, optimistic. Johannes?
I make it very short because Shane is running out of time. I can see him. So no, the exciting part is every car is connected, and every car uses these very nice facilities of edge computing, quality of service, precise positioning. That is the exciting part, and we can do a lot of things out of it. But we have still a marathon, and the marathon is the road infrastructure of the cities, of the road operators, to digitalize them and to get access out of the information which is provided by the road operators. Yeah. Not by proprietary networks, but by cellular networks which are everywhere there, which can be operated in a quality of service manner, and every customer on the road has access to this information. This needs to be understood by the road operators, but we are here only at the beginning, and this is definitely a marathon. So that's a challenge. The exciting part is the car industry, which already understood the whole thing completely. Thanks.
Great, thank you. Well, thank you, Johannes, Tim, and thank you to the GSMA, and for all of you for attending and listening. Cheers.